Hello, everyone. Andy McGovern here, along with Andresa Silvera. And what we're going to be doing is we've put together a short series of technically focused demonstrations of Irwin Data Modeler. We're going to have a lot of different topics that we're going to cover in very short segments. We're going to focus on this session on reverse engineering, and we're going to be very specifically walking through just the steps that you need to work with the data modeler in order to be able to create logical and physical models by reverse engineering your physical databases. So how are you doing today, Andresa?
I'm doing great. Thank you for asking. Can't wait to see the steps to reverse engineering.
Well, if you're seeing this for the first time, we're kind of in trouble, but
No, but I always like to see how you do it.
all right. So let's make this official. These sessions, and as you go through this library, you probably can hear me say this a few times. The whole point of this is to supplement the information that is already available to you from either from the help files, which is literally where this comes from, and any additional resources. So we're going to tie it together and make it easy for you to understand what you're doing without having to go into the full manual. But at the end of the day, please read the friendly manual because all of this good information is available in there. So let's talk a little bit about reverse engineering, why this is important. And from all of our customers we're working with, Andres, I think almost all of our customers are have some sort of initiative where they need to reverse engineer their databases and get a handle on what they have. Would you agree?
Yes, definitely. That's one of the biggest use cases we've seen. Most customers, especially for documenting legacy databases and to help with understanding what you couldn't have in place before you can start your new developments.
Yeah, they need to know what's out there. Just for everybody's edification here, when Irwin builds models, we're going to build logical models and physical models. And the process we're going to look at today is to build a logical physical model. We're going to have another session talking about the benefits of logical modeling, physical modeling, and even conceptual modeling. But what this process performs is the ability to see what you have and present it two different ways, either as a physical model or as a logical model. So as you're going to be testing this on your own systems, please just keep in mind you can only reverse engineer into a blank model. Reverse engineering is the first steps that are set there. And as Andres and I have been talking, primary reason for this is to understand how everything is put together and then build on it, and then use this process as your starting point to move forward to re-engineer your structures, provide documentation, whatever you need. This is going to make everything is basically establishing the standards, identifying what you have, and then using that information to proceed. So it was a very simple process. I broke it down into 3 steps. The optional step we're going to leave here, and that's to save your database queries to a trace file. Generally, you'll do that if you're going to be working with tech support for troubleshooting. But here's where the steps. We're going to select our model details. We're going to select the options, and we're connect to a database and reverse engineer. All right. Sound like a plan, Andresa?
Yes, let's go.
All right. So here we go. We're going to be doing this in Irwin Data Modeler 2020 R1. The actions area is where you're going to go to reverse engineering. We'll simply activate the reverse engineer wizard. Now we're going to be focusing specifically on creating a logical physical model on a SQL Server environment. Keep in mind that we do support a large number of DBMS systems. The configuration for these may be a little bit different. The trick here with any of these is make sure that you have already created and tested your ODBC connection into the database, and that will make this whole process seamless. So just to kind of quickly talk about this dialog here, you can create a logical physical, you can create a physical, you can match a template. We're going to cover templates in a different session, but that all the information could be contained in the template. And then if you're going to work with a template, you can browse to it either here, if you're working in the standard edition, or in the Mart if you're using the Workgroup Edition. Now, each reverse engineering wizard will have its own features and options available to it. This is everything, this is everything that's available in a Microsoft SQL environment. You can reverse engineer from a database or using a script file. Now, some of our DBMSs that we support can only do directly from the database, and that would be PostgreSQL and Redshift. But everybody else, we can reverse engineer either directly from the database or from the script file or the DDL. Now, the reason we have these options here, we're going to do with all of the options, but as a power user, you can create your own option sets and then save them off, because maybe you don't need to pull all this object information back when you're doing a reverse engineer. There's an option here to inject the name standard mapping. Now, if you've worked with Data Modeler in the past, name standard mapping traditionally has been used to translate from the English and logical model into the abbreviated SQLish. We now have the option to use that name standard mapping to quickly create a logical model. When you have that in place, and basically it shows your abbreviations, what they're going to look like when they go into English, you can have that saved off as a spreadsheet. We can inject that into the reverse engineering process and then quickly create a logical model that's readable by everyone. And then over here are options. And this is where we can specify we're going to do system objects. We can filter our tables. But most important, or probably the one feature that our customers really like, is this infer option. Andresa, would you kind of give us a little idea as to how the infer option works?
Yes, so the infer options allows you to get a quick start when you're trying to document your databases that don't have the relationships stored on the database level. So we try to infer those relationships based on primary keys or relations. And when you select relations, you will have the option to do it from indexes or names. Of course, that is taking consideration that your indexes and names had somewhat a pattern that can be identified, but Irwin Data Modeler is not a profiling tool, so we're not going to go very deep into it, but it can give you a head start, and I recommend you double check those relations. But if you have no relationships stored on a database level, that will be very helpful to give you a quick start.
Awesome. Awesome.
Another comment I wanted to make, and that's regarding to the filtering options at the top. As you can see, we have very limited filtering capabilities when you connect to the database. So we only can do owner and also by table name. If you have additional filtering needs, I recommend you do a script file, because you can go to your database management tool, which in SQL Server case would be SQL Management Studio. Oracle will have their own, and they all gonna have their own database management tool. You can go to that and generate a script file with only the objects that you are looking to reverse engineer, right? In case you have a huge database and you only want to get 100 tables from it. As an example, you don't want to type in around tables, 100 table names in here. So I suggest you create a DDL with only those objects, and then you do a script file reverse engineering.
You know, that is a really good point, because you're absolutely right. When you go against the database, you could pull back so much information using that DDL from your friendly neighborhood DBA, right? It definitely helps you focus when you build the reverse engineer. Thank you for pointing that out. All right, and then we've got some other options here. The scheduler, this is all grayed out because we're going to cover that in another segment. But what we're showing you today, and we're going to have some other sessions, we're going to talk about complete compare, and then we'll have a session dedicated to the scheduler. We can now schedule your reverse engineers or complete compare either in the standard edition or in the workgroup edition. All right, now here is where we're going to make the connection to the database. Which again, depending on how your database provides for authentication, we've got a Microsoft SQL, so we could authenticate with Windows, Here's where we're setting the database information. We already did that when we started the wizard. Here's the authentication. Here's SA, since I'm going to be going native against that. The connection type is using a native connection, or as I mentioned, you can inject or use your own ODBC drivers within here. The server, you're either going to use the DNS name or the IP address. If it's local, you can use dot. And then for your database, you can specify that directly in here. And then this will also specify using an encrypted connection if we're going to be pressing the credentials across the wire here. Now I'm going to type in my password here, but it does remember your connection. So if you forgot your password, it's going to be there, but it'll be encrypted and set there. And now we'll hit that and connect. Now I choose the publication model because it's small and it's an example that's included with your Irwin Data Modeler build. And it works very nicely. So if you want to play along at home, you can, I recommend just going out to Microsoft or just Googling publication sample database and get that running in your Microsoft instance. So this way you can reverse engineer a non-production system. So as I was talking, we've reverse engineered the publication database. How's that, Andres? That's pretty simple, huh?
Yes, definitely. That can be done very quickly. And with the help of the scheduler, you don't even need to go through this process. So looking forward to see the options we will have on the scheduler.
Yeah, that is some pretty slick stuff that we have. Now, before I go, or before Andres and I go, before we get ready for our next segment, I want to point out some simple things. We're going to talk about creating models from scratch, but as you have this set here, we reverse engineered a logical physical. We created a logical physical model. So right now, this model only has one diagram, which is the physical diagram. So if we want to see this as an ERD, we don't want to flip here and go to logical because we'd have to keep on doing that. What we want to do is we just want to create a new diagram that's logical. So here's, we're going to go to our diagram. We're going to set up a new diagram. You'll see that everything comes along tabbed like this. The diagram is blank. Here's where we're going to specify that it's going to be a logical diagram. We can change around the name here. And we're going to auto-populate it. So that means any object that's in the model will be shown in this particular diagram. So it brings everything over. We'll close the wizard. Everything comes into a jumble. And then from here, to lay these objects out, you can go to diagram, and then we have the layout buttons: hierarchical, orthogonal, tree, circular, and symmetric. I'm always partial to orthogonal. And then we've got this set up, and now we have our logical diagram. So the first step to building and documenting your environment is reverse engineering. And we've just seen how we can quickly do that specifically in a SQL environment. And we reverse engineered, we created a logical physical model. We started off with our physical diagram, and then we quickly created a logical diagram based on that. So that's going to end our session. We will be back with more fun stuff to do with Irwin Data Modeler because, as you've heard, data modeling is cool. Thank you very much, Andresa, for your insight, and we will be back for another session. Stand by.